For my Year 3 pipeline module, I was tasked with researching and following an industry pipeline of my choice. This will be a full technical report on what I did, how I did it, and what struggles I encountered along the way. I've chosen to make this report in a video format for accessibility purposes. I attended an event called Let's Talk Games where I learnt the basic roles a technical artist has through a lecture by Jason Yong, an experienced technical artist at Rebellion North. He introduced me to the idea of a generator. A generator is a program that streamlines asset and level creation through procedural generation. This could be a building, a weapon, items stacked on a boat, or even an entire level. It has the potential to speed up game production and is essential for large-scale open-world titles. Jason's presentation focused heavily on a shantytown project by Marina Alexandra Bade, a senior technical artist at Rocksteady Studios, and, after contacting him about it, he sent me links to her development log for the project. Therefore, my initial plan was to use Houdini to build a similar generator, but for a simple dungeon level creator. This would pose my first hurdle. Houdini, while extremely powerful, was very expensive. Additionally, it was a software none of my tutors could help me with. So after some research and considering some alternatives like Unity, I landed on geometry nodes in Blender. I would create an entire dungeon generator using Blender's built-in tools. While not industry standard software, Blender is extremely versatile, and more importantly, it's free. Student loans aren't enough to afford software that costs upwards of £1,000. For this project, I would need to create a modular asset pack, create a generator using a Blender feature I was unfamiliar with, and create textures for the level. It was certainly an ambitious project. The first part of the project was researching the pipeline. Jason had kindly provided me with a lot to work with, but unfortunately it all used Houdini, so I followed a couple of geometry node tutorials on unrelated projects to get my head around how to use them, and I managed to learn the basics. I also researched games with a similar art style to what I was going for, such as The Legend of Zelda: A Link Between Worlds and Tunic. With a basic understanding of what was required, I started the asset pack. I made simple Zelda-inspired modular pieces using a tileset as reference. The design could easily be made more complex, but I wanted to focus my attention on the generator, so I only spent a day on it. Here are the results. While I did make a door design, I haven't managed to implement doorways into the generator. This would be outside the scope of my abilities at this point. After building the asset pack, I used the resources Jason provided, along with some YouTube tutorials for specific GeoNode functions, to experiment with a few things, and I came up with this generator. It uses two simple inputs for the size of the map, but doesn't support inside corners or complex shapes, only square rooms. The basic principle is to create a subdivided cube and take the normal value of each vertex. Depending on the direction the normal faces, the generator assigns different geometry and a different rotation value. Unfortunately, it didn't support more intricate shapes, only squares, so I started again. My second attempt was much more intricate. Instead of two inputs, it would read the geometry value of a plane, which the level designer could easily manipulate. The generator would then create a level using the same method of reading normals and assigning geometry and rotation. This, however, posed a different issue. The inside corners would be set to wall geometry or outside corner geometry. If you look at the normal direction of this structure, you can see the normal for inside corners and outside corners are almost indistinguishable. Fortunately, they have a slight angle difference, so I could simply copy the code for identifying the normal angle and change how strict or lenient the normal ID could be using the epsilon value in the compare node. This is the result, a dungeon where you can handcraft the floor design by simply extruding geometry from a plane. The generator identifies the different corners and walls using their normal orientation, assigning separate geometry and rotation to them. It replaces random tiles on the floor and wall with a damage version. The size input changes how large the map can be. This should always be larger than the dungeon. I could make this automatic based on the size of the original layout geometry, but that couldn't account for additional camera angles, so I opted on leaving it as a manual input. The geometry ID inputs change the geometry from the collection the assets are stored in. For example, corner inside is number 4 in the wallpack collection. It's important to note that in true programming fashion, the IDs start as 0, not 1. These are the geometry nodes. The inputs come from this node. It's duplicated here to avoid unnecessary routing and a cleaner, more organised workspace. The floor and ground groups create a grid and boolean the floor plan geometry created by the level designer and add verts in a grid pattern across the original floor plan. It then creates 3D geometry for the generator to read the normal value, as all of the normals on a flat plane face the same direction. The roof geometry section uses a simple instance on points node to add the flat floor geometry to the roof. The identify side group can be opened by pressing tab. It contains the code to identify what side the normals are facing. As stated earlier, it contains an identify normals group and an identify lenient group that hold the same function but have differing degrees of accuracy. We need both versions to differentiate between the inside and outside corners. The geometry IDs collection contains some switch nodes, which act like if statements to the normal direction and determine which ID they should use. The random wall and random floor tiles give a random ID between the minimum and maximum value set by the level designer for variation to keep the tiles from looking too repetitive. I originally tried to use materials to achieve this, but encountered a few issues with the material nodes, so stuck with geometry IDs. Wall rotation is simply rotating the wall depending on the normal direction. The walls are rotated in the pattern shown in this graph. Rotation values in Blender use a strange format, so the rotation Euler node allows me to rotate in the traditional 360-degree format. All these inputs are placed on an instance on points node, which sets the geometry to the selected collection, and uses the values from all the previous nodes to rotate and identify the right geometry to use. This is then combined with the roof geometry and output as a completed level. For the texturing, I first tried making a trim sheet with hand-sculpted bricks, but sculpting is extremely time-consuming, so I attempted to create a texture using Substance Designer. Before finishing my material in Designer, I received feedback from my classmates and decided to use pixel art textures instead. As the project was 3D, I wasn't happy with a simple pixel art texture, so I decided to hand-draw normal maps for the textures as well. To make a guide, I created a quick normal bake in Substance Painter that would act as a palette for my normal map. Unfortunately, Substance outputted a DirectX normal map despite labelling it as OpenGL, so I would have to flip the green channel after painting the bricks. I made the bricks in LibreSprite, an open source fork of Aseprite. The normals were relatively easy to make as I only needed to colour pick from the normal palette and could paint directly over my 32x32 brick texture. I repeated the process with the floor tiles and imported them into Blender. I then unwrapped the modular assets like a trim sheet and created alternative materials for the variation. And finally, rendered the result. As you can see, I can easily change the colour through lighting, but if I were to use this generator in game, I could add colour to the textures. I can also easily replace the assets or build entirely different asset packs using the same generator. Overall, I'm extremely happy with the result. I chose an ambitious task and I managed to achieve it. Some areas of improvements would be multiple floors, some decoration like lamps and pots, and some improved assets. Due to the way I modelled the asset pack, it was hard to get the UVs to align. I would also like to add a metallic and roughness map to the materials. I would like to give special thanks to Jason Young for the resources he sent me, Marina Alexandra Bade for her breakdown on her shantytown, and of course, my tutor for this module, Zoe. This has been an extremely challenging module, but I've enjoyed working on the project.